Okay, so let's get started here. We're going to talk about frequency tables or a frequency distribution. This shows how a data set is partitioned or divided among several categories, which we call classes. Okay, so if you take a look here, these are the winning scores for the first ever 42 Super Bowls, right? So, you know, like this year, the winning team had, they scored 35 points, then 33 points, then 16 points, and so on, okay? To make a distribution table, we want to basically split up all of these numbers into categories, right? Now, to do that, you have to look at the data that you have. You have to see, how the data is like separated to begin with, and that's how you figure out the categories or the classes to make. So you can see here, like the numbers, they go from, let's say, 14-ish to something in the 50s or 60s, right? What seems to be like the highest one here? 55, right? So it starts in the 10s and then it goes in the 50s. So when you make your classes, you say, okay, maybe I can divide them into like classes of 10s, right? So and so the range of the data is from 14 to 55. That's what you have to do first, okay? And there's 42 of these things. So you have to make your classes so that you have, not all of them in one category, and you don't have like one number in each category, right? So the way we are going to set this up is the categories are going to go like this: 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59. What's super, super important is that the categories have equal length. So here, from 10 to 19, right, you have 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. You have 10 numbers in each category. This has to be the exact same thing from 20 to 19, 10 digits, and so on. It can't be like sporadic. And then literally what you do is you tally it just like you did back when you were in elementary school, right? So how many of these fall into 10 to 19? Okay, so you literally go and you tally, right? So for example, like 35 falls in this, you put a 1, and so on. And then once you do that, you count. There are 5 in this category, 16 here, 15, 4, and 2, right? Always make sure that you've counted all of them, so you have 42 total, which is how many you should have had. Okay, so now this is important. These values here are called the frequency. Okay, it's how many in each. That's it. It's just the frequency. Then, when you take the frequency and divide it by the total, you get the relative frequency. So in this first case, there were 5 here, 42 total. 5 over 42, or 0.12, is the relative frequency. You can either give it in reduced fraction or decimals. Different types will be useful to you in different situations. Okay. Now, let's talk about class boundaries. Class boundaries are the numbers that are used to separate the classes. So for example, one class is 10 to 19, another one is 20 to 29. All right? Class midpoints is halfway between each class. So what's halfway from 10 to 19? That's the class midpoint. Okay? All right. So for this one, let's do some of these. Class width. Right? It's how many are in each class. So from 10 to 19, 20 to 29, it's 10 in each class. That's the class width. Okay? Remember, this is going to be the same across. 10, 10, 10, 10. Okay. Lower class is the first number in each of your classes. So it's 10, 20, 30, 40, 50. So then what would be the upper class?
19, 29, 39, 49.
Correct. 19, 29, 39, 49, 59. Okay. Now, let's take a look at class boundaries. This one starts at 19, that one starts at 20, correct? What's halfway in between them? 19 and a half. So that's the class boundary. Okay? 19.5. All right, and then so for the next one, between 29 and 30, it's 29.5, 39.5, 49.5. So these are things that you just have to like memorize, and then you have 59.5. Okay, midpoints halfway between each of them. So the first one, if it goes from 10 to 19, right? To find the midpoint, you just do 10 plus 19 divided by 2. How much would that be? 14.5. Okay, and you do that for all of them. So 14.5, 24.5, 34.5, 44.5, 54.5. Yeah. I mean, it depends, right? So it's kind of tricky if you went by if you went by tens, it's very, very easy. But if you went by fives, you have to do a little bit more thinking. Yeah.
Why, for the class boundaries, why is it 59.5?
Because you also go, like, the boundary for this one is 59.5. Oh, I'm sorry. I should have also put the 9.5 up here, like at the very front. Because you also go in the beginning and in the end. Okay? So 9.5 as well. Yeah. Okay. All right, so let's go here and let's make a frequency table of this. Of the lab grades here. Okay. All right, so I want to make a frequency distribution of the lab grades of a biology class that is given below. Okay, so it says to use a logical class width. Okay, most of the time you're not going to be given how many, because that's the whole point, is for you to decide. So let's take a look here. What's the lowest score?
63.
63?
Yeah, 63.
And what's the highest?
98.
98. Oh. Okay, 63 to 98. All right. So, and then how many of them do I have? 1, 2, 3, 4, 4, 5, 24 of them total, right? So if I go from 63 to 98, how do you want to divide up the classes? How do you want to do it?
We could do it like, yes, 60,
Right,
69.
by tens, right? Okay, so let's do that. So here you will have grades. So we start from 60 to 69, 70 to 79, 80 to 89, 90 to 99. Okay, and then you're going to tally, and then you're going to have the frequencies. Okay, so okay, so there's like several ways you can do it. You can either like go through and do all the 60s first. I find that to be faster. So look, I have 1, and then 2. Is there a third one? Yeah, 3. So if you do it this way, you actually don't need the tally column, right? I could just say 3 for the frequency, right? Grades, sorry. Right? You could do it this way. Or you could just go one by one and say 72, put a tally mark, 84. I find that slower for me. Okay, so let's do the 70s. You don't have to, is what I'm saying. What we really need is the frequency. How you count, that's up to you, because, you know, at this point we're, you know, good enough. Okay? So once you do that, right, just count 10, 19, 24. And we did have 24 in here, so make sure they match up and you haven't missed one. Okay? Now, after that, we need the relative frequency. All right, so for the first one, it's 3 over 24, which is 1/8. 7 out of 24. 9 out of 24.
We don't need to put them in decimal.
You do. We're going to do it. I'm trying to be as efficient as I can. 9 over 24 is 3 over 8. And then 5 over 24. Okay, and can someone help me with the decimals here? 1 over 8 is 0.125, right?
Yeah. Actually.
7 over 24.
0.2996.
How much? 0.29.
1668.
Okay, and 3 over 8?
0.372.
And then 5 over 24, you guys know how to do. All right? So that's how you do a frequency table.
I don't know how to do it.
Plug it in your
Just plug it in your calculator.
But for some reason when I plug in
Press Control Enter.
yeah,
So do 5 divided by 24, Control Enter.
she knew what you were gonna say.
I know. Okay.
Oh.
Yeah.
You
Mhm.
can just put a period
Wait, have
after
you
it.
never gotten decimals?
Huh?
You can just
Yeah,
put a
let's
dot.
not complicate things. One at a time. One thing at a time. One thing at a time. So Jeremy is saying you can also do like 24 dot enter. Control enter is always better because there was like a glitch involved with that one. Anyhow, okay. Let's move on to histograms. A histogram is a bar graph. Okay, it's a bar graph out of these. The thing about histograms is they cannot have gaps in between the bars. Okay, so that's the difference between a histogram and a bar graph. The horizontal scale represents the classes, and the vertical scale represents the frequencies. So you basically make a table like we did here. Then this will go in your horizontal scale, and this, or the decimals, will go on your vertical scale. All right? The frequency, the relative frequency, one of those will go on your vertical scale. Okay. Okay, you have an example of histograms here. So take a look. This is the histogram for the very first Super Bowl problem that we did. Okay, let's take a look at some of the things that we have here. First of all, you have a title for your histogram. It's meaningless if there is no title. All right? Your x-axis and your y-axis are labeled, scores and frequencies, and then the x-axis and the y-axis are calibrated with equal length. So these are obviously going to be equal because that's how we set them up. This one, do you see how it goes up by equal numbers? 0, 4, 8, 12. So they go up by 4s. You can have it go up by 4s, you can go up by 2s, as long as it's the same. So you can't go up by 2 and then by 6 and then by 3, right? They have to be uniform. Okay. So the one on the right is for the relative frequency. The one on the left is for the frequency. Okay, so if I scroll up here, right, this is what they made into a histogram. It's this table. So one graph shows the frequencies, another histogram shows the relative frequencies, right? And you see the markings on the side are different. One goes up by decimals, 0.2, 0.4, 0.6. Okay, the point I'm trying to make is when you have a histogram, right, just like this, if I just showed somebody this, the way all of these are labeled, there should not be any other need to explain what this is about, because just by looking at this, I know these are the winning scores of the Super Bowl. I know these are the frequencies, so I just know. Okay? So it has to be self-explanatory. Do you notice there are no bars in between, there are no gaps in between the bars? That's important. Okay. So let's make a histogram of the lab grades of the biology class. So first we're going to title this lab grades. Okay. On the bottom, I have an axis. That's grades. Here, I have another axis, frequency. Okay. Yeah,
So we can choose whether we want to do relative.
it'll tell you.
Oh.
Yeah, it'll tell you very specific. Okay, so the frequency, the vertical axis goes 3795, right? So maybe we can go up by, ones up to 10. All right, so here's how I'm going to do this. I'm going to make this a 1. Do I have enough? 5, 6, 7, 10. All right? Okay. And then the classes, we started with the 60s. Count how many squares you want to make a bar. I'm just going to do like 4 so I have enough room to write in. 60 to 69. 1, 2, 3, 4. That's up to you. 70 to 79. Okay. And then we put in our bars. So I have, what were they? 3795. So first I go up to 3. Then 7. Then 9. Then 5. Okay, there we go. If I had some test scores, right, and if I sorted the test scores from lowest to highest, and if I divided it into 4 equal parts, what I've done is divide it into quartiles. That's all quartiles are. Q1, we call it the first quartile, is basically the bottom 25%. Q2, the second quartile, it's the bottom half, 50%. Q3 is the bottom 75%. Okay, so take a look here. You have some quiz scores here, right? How many quiz scores are there? 1, 2, 3, 4, 8 of them, right?
Oh, not number 9.
The example over there. So you split it down the middle. That's the median, or Q2. Okay? Now what I have is that median, the green line, it separated the test scores into 2 equal parts. The left half is the lower half. I do the median of that, right? So this number 29 is the median of that. I call that Q1. The upper half, I do the median. This number 35 is Q3, right? So now what I have is, this is the bottom 25%. This is the bottom half. This is the bottom 75% and the top 25%, right? So that's how I've split it up. Okay. So that's Q1, Q2, Q3. All right, so let's put these into quartiles. All right. The first thing you have to do is you have to make sure your data is sorted from decreasing to increasing, which this one is. How many total are there here?
12.
Okay. N equals 12. Okay, awesome. So split it down the middle. We have 6 and 6 here. Okay. All right, so this is Q2, or the median. What number is that? If it falls in between 2 numbers, you take the average, 84. Okay, now here, I'm going to split this into 2, which is right here. That's my Q1. And what's that number going to be? 74. Okay. Here, split this. What's that number going to be? Q3. 91.5. Okay. We always go 1 decimal place more than what we're given in. These are Q1, Q2, Q3, right? Easy as pie. Okay, these are three numbers. If I add to that the minimum and the maximum, now I have 5 total numbers, and I call that the 5-number summary. So often, you will just be asked, here is the data, give me a 5-number summary. You don't raise your hand and say, I don't remember what this was. You know it's minimum, Q1, Q2, Q3 maximum. Okay? Always. So here, same example, to create a 5-number summary, you say, okay, minimum 65, Q1 74, Q2 84, Q3 91.5, maximum 98. Okay? Now, what can we do with a 5-number summary? We can create a box plot. Who's heard of a box plot before? Or a box and whisker plot?
Oh, yeah.
Okay? A box and whisker plot is also called a box and whisker diagram. Okay, so here we go. The first thing you have to do is find the 5-number summary.
That we did.
Okay, that we did. Next, you have to construct a scale with values that include the minimum and the maximum. So basically you have to, this is a number line. You have to construct a number line that includes the minimum and the maximum. So like from 65 to 98. And then you calibrated it like equally, in equal intervals. You make a box going from Q1 to Q3, just like this. Okay, you make a box like that. You draw a line at the median value here. That's your box. Then you draw lines to the minimum and the maximum. So here's the minimum, here's the maximum. You draw lines from that. So what you have is a box and its whiskers. Okay? All right. Okay, so let's do a box and whisker plot here. Okay, so first, is this data sorted?
No.
Well, it is. It's just in like reverse order, but it goes from like biggest to smallest, which is good. Yeah? Yeah. Okay, so this time this is the maximum, and this is the minimum. So how many total are there?
Wait, total what?
13. Numbers, 13. There are 13 values. Okay? So the median then is which one? Which one is it? Right. That's Q2 or the median. Okay. This is the bottom half in the bottom here. Okay. It's very important for the bottom half or the top half, you don't take Q2 with it, right? Just this stuff here. So 1, 2, 3, 4, 5, 6. That means it's going to be in between those two right here. You take the mean of those, and that's 14316. 14316.5. Milan, can you close the door over there, please? Good. This is Q1, right? Remember, it's in the bottom half of the data. Okay? And then this one here, the middle of that one is 22913. That's Q3. Okay. So, first thing we need is a 5-number summary. All right, the minimum, 2022, Q1, median, or Q2, those are interchangeable, Q3, and the maximum. Okay. Now, to make your box plot, you need a number line. And the number line has to include the minimum and the maximum. So it's up to you where you want to start and where you want to end, but you have to go in equal increments. So for this one, why don't we start at 0, right? And I'm going to go up by 5,000s here, right? So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. This is the part where most students mess up because they only put in the numbers in their 5-number summary, but you have to have like a standard scale, like a ruler. So 35, 40, 50, 55. Okay? Okay. Let's put in Q1 is 14,316, right? Okay, so it's going to be in between these two, closer to the 15. We estimate a little bit. Then Q3 is 22,900, somewhere here. Make that into a rectangle. The median is at 18,006 right here. And we're going to say this is Q1, median, Q3. Maximum is 52,000 here. Minimum is 2,000 here. Line, line, we're done. Oh, I went a little too far. Sorry, thank you. I went a little too far because I meant to go up to 55 only. So it's here. Good. So the requirement is you have to have the 5-number summary listed here. And then here, you can just label with the names minimum, Q1, medium, and so on. Okay? All right. What does this tell you about the enrollment in state schools in Ohio?
Not the highest enrollment in all of 2010.
And like, so it's concentrated where?
From like 14 to 22.
Right, it's concentrated between like 14 to 22,000, right? Like, so do you see like from the first minute that you lay eyes on this, like these are certain information that you can figure out, okay? So enrollment concentrated or enrollment in a university is concentrated between, you know, like 10 and 25,000. Okay? Like in enrollment within a university is you know, concentrated like that. Okay, let's use our calculators to do this. Go ahead and take out your calculator. Yes. Okay, so we put in the quiz scores. We did this. We named the list. Okay, and now let's go here. So press the on button again, and then the histogram button, the purple. The on button, and then the purple one next to the spreadsheets. Okay, this is all your data. Do you see how it's everywhere? Just click here, and it already like tells you, are these the quiz grades? Yes, these are the quiz grades. So just select quiz and press enter. Look at how it sorts them for you. Okay, press on. Guys, you can also follow the paper.
Yeah, but like something else.
Okay, so press on and then this purple button. Okay, then you have all of the data like this.
No, I'm like at this.
Right there, press the on button. Okay, Sarah, maybe you and I can take a look later, okay? Click. Click to add variable and then quiz.
Whoa.
Okay? Then, okay, this is the important part. Watch. Menu, plot type, histogram, and it gives you a histogram like this. Or you can do menu, plot type, box plot. It gives you a box plot. Okay? You know what? Hang on. Stop.